Okay, I'm not sure what happened with my video. I must have stopped it when I was going through the problems. I got kind of far down here. But here's number 1. And the reason why I was able to set both of these equal to each other is because of this information that's provided. It tells us that these two arc measures here are congruent to each other, and so I could set the chords equal to each other. And so I end up with 7 here. On this question over here, we know that if we add up all of the arc measures together, we'll get 360 degrees. And because they give me this one, if I subtract 70 from 360 and get 290, I know that this arc measure here and this arc measure here have to add up to that 290. Well, because the chords are the same, that means that these two arcs are the same as well. So I'm able to take 290 divided by 2 and figure out one of those arcs is going to be 145 degrees. So that's number 2. Do 3 and 4 on your own. Moving down to numbers 5, 6, 7, and 8. I'm given all this information over here that the radius is 18 of this circle. And remind you that it's not just the lines that are drawn as the radii already. So we know, like, N to, what's this letter down here? E. N to E is a radius, obviously. N to G is a radius, but so is N to D. That's also going to be 18. N to X is also 18. N to Y is also 18. So remember those properties about what a radius does. We're also told that N to K is 9, so I wrote that in here. And then the arc measure of D to E is 120. So that's all the way from D to E here. Number 5 is asking what the arc measure is from G to E. I put down 60 because G to E is half that measure, and that's part of the properties in your book on page 662. Oops. 662 looks like this. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord in its arc. So that is part of those theorems that we're using. And so that's why we were able to just simply cut 120 degrees in half to be 60. Number 7, on the other hand, it's asking what the measurement of angle HEN is. And HEN is located right here. It's this angle that's created right here. And so I drew a triangle a little bit bigger to still represent this triangle. And I'm able to deduce that this angle coming off from angle N is a central angle from the circle. And part of concept number 1 was knowing that central angles were the same as the arc measures out here. So if this arc measure that we just did for number 5 is 60 degrees, that also means that central angle is 60 degrees. So that's why I labeled this as 60 degrees. If this is a 90-degree angle, that only leaves 30 degrees as an option for angle E. And so that's what we have right there. Okay. The last few problems, 9 and 10, you'll be looking at theorem 9.5, which is right here at the bottom of page 663. In the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So again, this is page 663. So I am able to set, because these two chords, this one and this one, are equidistant from the center, I can set 3x equal to 7x minus 20 and solve for that. 7x minus 20 equals 3x. And I can subtract 3x from both sides, minus 3x over there, minus 3x over there. I get 4x minus 20 equals 0. I can add 20 to both sides. And so then I have 4x equals 20 and divide by 4. And so x is going to equal 5. All right? And try your hand at number 10. And then everything that we've learned so far, all those theorems, see what you can apply for number 11. Good luck.